On this section, we're going to talk about dividing polynomials. Now, this is just a tool that we're going to use later on, but we have to talk about it because it's tricky within its own right. So first off, whenever we're dividing polynomials, we have some polynomial divided by some linear polynomial. Okay? So first off, we're going to use something called synthetic division. Let me write that up there. Synthetic division. Now, in and of itself, it doesn't make much sense, but once you learn it, it's something that we use to do division with polynomials. So let me go through the steps real quick. First off, when we're doing synthetic division, we are dividing by a certain x value. So right now, I'm dividing by a binomial. So I need to set that equal to 0 and solve for a certain x value. I'm going to set this up like this. I'm going to take my 4, put it there. The polynomial I'm dividing, I want to write out all my coefficients spaced out over here. It's important to point out that we are missing an x term. Okay? We need to have all of our coefficients accounted for. So if we are missing a term, we need to put a 0 in for that term. Okay? So over here, if I write out all my coefficients, I have a 3, -2, I'm missing an x term, so I put a 0, and -150. Gap down a little bit and put a line. And here's the process of synthetic division. I always drop the first number down, multiply times this guy up here, so that's times 4. So we get 12, add straight down. I get 10. Again, multiply by 4, and we get 40. Add straight down, 40. Multiply again, 160, and you should get 10. Now, I have this line separating this very last number. That's because this guy is our remainder. Okay, the way we write this, we start here, going this way. This is going to be my constant, x term, x squared term, and so on and so forth. However many we have, then I add my remainder on at the end. So this becomes 40 as my constant, 10x is my x term, 3x squared is my x squared term. Then I take my remainder and I add it back on by it divided by what we were originally dividing by. Okay, it seems confusing, but once you do it several times, you catch on pretty quick. And so let's do some more examples. So you have 5x to the third minus 6x squared minus 28x minus 2 divided by x plus 2. I take my x plus 2, set it equal to 0 and solve, which gives me -2. I do not have any missing terms in my polynomial, so that is just going to be 5, -6, -28, -2. Drop the first number down, multiply, then write out my answer. I have 4 as a constant, -16x as my x term, and 5x squared as my x squared term. Then I'd have my remainder over what I was dividing by. Okay? Well, say I'm given this. Say given, and this is kind of getting into stuff we're going to do in the next chapter. It says given f of x equals -x to the 4th plus 3x squared minus 4x minus 5. What remainder do we get when we divide by x equal to -3? Okay, so again, with synthetic division, we are doing it with a specific x value. So here we don't have to divide or set equal to 0 and solve because we are given an x value. We are missing a term. Up here you can see we are missing a x to the third term. So we have -1, 0, 3, -4, and -5. This only asks what's the remainder. Okay, so when we get done with this guy, all we care about is the remainder. And then 14 times -3 is -42, so we get -47. So the answer to the question is the remainder is -47. Okay, now, next question is what can we divide by using synthetic division? We can do it with whole numbers, we can do it with fractions, that's not a problem. The next question is can we do it with complex numbers? And we can. So let's do an example of doing synthetic division with a complex number. Now you don't always have to do this because there's ways of getting around it, but it is possible. So let's say I have f of x equals x to the fourth minus 2x to the third plus 4x squared plus 2x minus 5, and I want to divide by x equal to 1 plus 2i. Okay? Now, the arithmetic is just going to be a little bit more cumbersome here. So, up here at the top, I'm going to go ahead and do the synthetic division, but I'm going to have to use the bottom for doing some arithmetic. So, I don't have any missing terms, so I have 1, -2, 4, 2, and -5. Okay? Let's drop the first number down, then I have 1 plus 2i, which gives you -1 plus 2i. Then I need to do 1 plus 2i times -1 plus 2i. Okay, so I'm down here, I'm going to do that on the bottom. It's going to give you -1 plus 2i minus 2i plus 4i squared. These guys cancel. I have -1 minus 4 because this guy's just -1. And so it's -5. So back up here I get -5, -1. -1 times that is -1 minus 2i. Then we get 1 minus 2i. Again, I'm going to do 1 plus 2i times 1 minus 2i here on bottom. 1, -2i plus 2i minus 4i squared. Again, these guys cancel. This here just makes this plus 4, so we get 1 plus 4, which is 5. So we get 5 up here and we get 0. Now this right here, a remainder of 0 is something special. Okay, so we're going to talk about that in the next section. What happens when we have a remainder of 0, and that's a very, very good thing. We'll talk about that in the next section.